Hello, everyone. So, the experiment or the sample I was assigned looked at a random sample of 80 kangarams from the planet Z, if I remember correctly. And what we wanted to figure out is out of these 80 kangarams that we randomly selected, how many of those are adults? So, as you can see in this table right here, the one if there was a 1 next to the subject, um, that meant that they were an adult, and if there was a 0, obviously that means that they are not an adult. So in this particular sample, we have 49 adult kangarams and 31 non-adult kangarams. So our mean, this brought our mean to 0.613. Since it's closer to 1 than it is to 0, we of course know that that means that there is more adult kangarams than there is non-adult kangarams in this particular sample. And when we come over here and look at columns R and S, we can see that that's pretty much par, of course, for like every single sample. Every single sample is above zero point 0.5, which indicates that in every single sample we drew more adult kangarams than we did non-adult kangarams. So this table right here is the table that we were able to get our data and bring it over to this next worksheet. So this is the exact same data that was on the other sheet. Sample proportion 0.61 for the first sample, as we can see here, 0.61. So as I said, that's the exact same data. We just brought it over to this next sheet, and then we just simply rounded it. So in these next two columns, so in column C, we rounded it to the nearest tenths place, and in column D, it looks like we rounded it to the hundredths place. And this is, I guess, or never. We use this data and transferred it. Column C is this table right here, our first table here, and then column D is this table, corresponds with this table right here. And then using these frequency tables, we were able to make these histograms over here. Obviously, the mean remains the same on both histograms, so the mean is 0.64 for both. The standard deviation is 0.05, which, yeah, okay, which is not correctly shown here. That should be a lot smaller. Each one of these should be a lot smaller. Alright. So the standard deviation is 0.05, very small. So to make sure that my data and my histograms lines up with the data in the sample, or samples rather, that we took on the last page, I went ahead and we'll look at this particular bar right here in the histogram. So this value is for 0.650. The value percent is 36%, so that's right here. Oh, did not mean to do that. Anyway, so this is 0.650, as I said. So we can see that the frequency it is 18, so it popped up 18 times over here in column D. So I went ahead and highlighted each cell that has 0.650 as its value. I went ahead and highlighted those yellow so it'd be easier for us to count up. So what we're looking for to make sure the data is correct is to make sure we have 18 yellow cells here highlighted. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we know that data lines up pretty well. So as we can see looking at these histograms, The only difference, the data is the exact same. The only difference is this histogram, uh, the bins have a larger range, while this histogram, the bins are um, more precise. So the range of each bin for this histogram, as I said, since it goes by tenths, is 6/10 all the way to six point or 0.699 while this one um, takes into account the hundredths place. So of course it's gonna be, as I already said, more precise. So as we can see, the distribution on each of these looks very, very different. The first histogram, it doesn't look like there's really much difference. I mean, it looks like there's almost like two outliers. I believe the value's two. Yeah, so there's like, it looks like there's almost two outliers here. And then these two bins, it looks like it's the norm or what it should be every time. But when we look at this histogram down here, it doesn't really look like there's any outliers, as it's a nearly normal distribution. Obviously, there's a little bit of variation between these bins, but the spread looks pretty normal. And that's really all I have for this video. Go ahead and end it there.